Welcome back, folks. Here we are at the end of week 7. It says we're going to do a bit of catch up today. If anything, we're just going to be first doing a bit of things on methods. A couple days ago, we introduced what a method is. We should probably apply it to a few more projects. And this way, it'll make more concrete. And then later, towards the end of class, we'll go over a practice midterm. All right, the actual midterm is going to be scheduled for next week. It's going to be on a Monday at the same time as this lecture starts. It's going to be an online Canvas quiz. I'll have some information on this towards the end of class. But let's talk about methods first. We need to do a bit of catch up on this. All right. So just a bit of review. All we really did last class was write a couple of small functions, methods. I mean, we did here methods.java. We ended up writing like a couple small functions, and then later on we took it a step above, and then we did something called volume methods. This is some more methods. In particular, these are non-void ones. They return doubles. And then we took it a step further and did this vowel counter, which was a little trickier to understand. If folks had trouble understanding this from last class, it's okay. This should make sense by the end of today, though, because we're going to do a few more examples, and hopefully people see what a method is. All right. So let me just quickly review stuff. Hopefully people have seen this before. So we've done all of these block boxes a couple days ago. Let's do it again, but apply it to previous projects, because our goal is to promote good programming practices. It's arguably a good programming practice to have a modular design, meaning that if your program is easy to take apart, then it's going to be easy to fix. And if you were to have like modularity in the program, like functions that do small things, you can reuse them. Right? You can reuse them so you don't have repeated code everywhere in your program. All right. So hey, let's go ahead and apply this to a few old programs. Maybe we should visit. Let's go ahead and revisit FizzBuzz. All right, FizzBuzz, if you might remember, this was it's like an interview question. It's kind of like a metaphor for one. Let me pull up my old slides over here. Give me 1 second, folks. Yeah, a couple of weeks ago we did something called FizzBuzz, and I kind of motivated it by talking about technical interviews. If you're planning on doing like an engineering job, or maybe software or a computer programmer, it's likely that they're gonna ask you if you can write a loop in the interview. And this is a metaphor, so they're not gonna ask you exactly this question, but it's gonna be similar. It's gonna be something like, hey, can you write a loop that has some conditions in it? And that's pretty much what this FizzBuzz is here. It's given some upper bound. The upper bound doesn't really matter here. I just hard-coded an n here. But basically, given some upper bound, you want to count up to that number and print out FizzBuzz or FizzBuzz. All right, so hopefully people remember this from a couple weeks ago. Let me go ahead and run this, compile it. Compile and run. See if it still runs. Okay, cool, it still runs. Let me verify the output to see if it's good. Okay, 0 is FizzBuzz, 3 is Fizz, every 3. Yeah, this looks good. 15 is FizzBuzz because it's both divisible by 5 and 3. And then, okay, yeah, this makes sense. Cool. So a possible way we could take this apart, you can represent this whole thing in a method instead. The reason why this might be useful is so you can reuse this loop. Like if you wanted to do fizzbuzz up to a certain amount, you could generalize this loop to a different number. Because currently you see how we have like a hard-coded 100. Well, one way we could do this is kind of just move this into a method, like kind of take apart our program. So, well, what I'm saying is, imagine if here I'm gonna cut this. I'm gonna cut all of this. So imagine if we had a method here called fizzbuzz. Okay, so this doesn't exist, but let's say I gave it like 100 over here. So let me erase that hard code and like let me say I put 100 here. People see what I'm trying to do. I'm trying to invoke a method that prints all the numbers up to 100. All right, and I'm building it from the bottom up. Like bottom up meaning I'm assuming this exists, but it doesn't exist, because if I try to compile it, it doesn't even compile, so it won't run. So bottom up will help us kind of visualize the goal of this program. All right. So can people tell right off the bat what the method can look like? Like what is the first line in the method gonna look like? All right, let me pull up the syntax real quick. Okay, the syntax. So here's what a method kind of is defined as. If you look at this top over here, we see that. Well, first of all, you can ignore public static. This is stuff from older Java. It does work in newer Java, but it'll make more sense when we talk about OOP, the object-oriented programming. Anyways, a method starts off with a return type. So by reading this, can folks see what this returns? All right, what's the return type? Well, based off how we're invoking it, we can kind of see it's a void method. Remember how void methods look like this over here? So a void method is it's like a black box that does something but doesn't give any output. All right, this input doesn't really matter here, but a void means there's nothing coming out. All right, so from last class we did this void greet. It took like a name and then it just printed it out, and then when we invoke it, hopefully people see what it means to be void. Right? It just means that it wouldn't make any sense to say something equals this, right? Because this black box does something. It doesn't need to give the caller any information. All right, so we can kind of implicitly tell this is a void method, meaning that we should use a void here. All right, so I'm making a method called void. I'm not called void, but it returns nothing. And then next we need the method name. Right, the method name doesn't matter too much, but for here we called it fizzbuzz. So let me go ahead and call it fizzbuzz. All right, and then next up in the method, we need some parentheses. So we got these two parentheses that describe the parameters. All right, so let me get these two parentheses and describe as parameters. All right, so what's a parameter? Once again, a parameter is it describes the input to the method. So in this case, how do we describe the input that we're sending it? All right, see 100. Right, how do we describe this? One way we can describe it is as an integer. So we could say this is an integer. I'll probably call it like upper bound or something. Right, you can call it whatever you want, because whatever number, whatever argument you put in here is going to be substituted into this upper bound name. All right, and then next up we need two curly braces. These curly braces will represent the body of the method. Okay. Okay, so this is pretty much what the syntax of it looks like. Let me go ahead and do a print statement in here real quick just to make sure it runs at least. I'll just say starting fizzbuzz. Okay, so I'm just gonna say starting fizzbuzz, ... Let me just make sure it compiles and runs. Okay, cool. It compiles and runs. Okay, great. Now we can go ahead and carry on. Oh, here's a quick quiz question, by the way, folks. A possible exam question is, what is the output if I did something like this right here? Alright, so a possible quiz question is, what is the output of this program? Is it going to print this first and then this next? It kind of looks like it because this is the first statement and this is the second statement. It looks like it, but it's actually the opposite. This is kind of a big takeaway on the structures of a lot of different programming languages. In this case, the main is the entry point. It's in a lot of languages. Basically, when you run the program, it's the entry point goes to the main, which can depend on other methods. Alright, so that's why this prints first, and then we move on to the next ones, which traces up to here. Alright, so that was a possible exam question. Anyways, if folks are having trouble like understanding the syntax for a method, and if the reading doesn't work out for you that well, you could also Google stuff up like methods in Java and look at the primary documentation. The primary documentation might be hard to read, but it does have a lot of information. So this is the primary doc right here. Oracle is like the primary. So yeah, you could look through this if you're curious. Actually, no, I wouldn't recommend this yet. It doesn't look like it has too much information. I'd recommend the readings, the MOOC Java over here, 2.4. So this one is going to be a little easier to read. Okay, anyways, let's get back to the point. So our goal was to do FizzBuzz. We passed in 100. Right? This argument doesn't matter, but it passes up into here, and now all we need to do is a loop that iterates through all of the lower numbers. So I do have it copied already, so I'm just gonna paste it here. Right, actually, yeah, I'll just paste it here. Let me fix these indents. Typically when you have curly braces, the things are indented. This way you can kind of see what belongs in what. Okay, so all I did was copy and pasted the old loop, the old for loop. We do have to change, like, I think one thing though. Can folks kind of predict what we have to change? Like, let me see what happens if I try to run it. Right, so let me run it. Java FizzBuzz. Okay, so it didn't even compile, so we didn't even get to run it. All right, what happened here? Let's see. So it says line 3. It says cannot find symbol n. All right, so it's pointing at here for some reason. All right, what's happening here? Any fixes people can think of? All right, there's an error right there. Now what's going on? So there's a few ways of fixing this. But basically, this n was our old variable. Right now we changed our name. We changed it to upper bound. So this condition should be upper bound. That is one way of fixing it. You could also change it, both of these, to n, but upper bound is probably a little easier to read. All right, so how this works is 100 gets sent up into here, and then we loop about 100 times, 101 times, I believe, because we start at 0. All right, so let me test this real quick. So Java. Then cool. So it prints all the way up to 100, and this is a little more modular, by the way. This program design is more modular because now we can pretty much reuse this method whenever we want. All right, you can collapse this, by the way. So I'm going to collapse this just to make it a little easier to read. You can collapse functions. It's still there. It looks like it's deleted, but it's not. So this is like a Lego piece. We can use this Lego piece on our main. So if you're planning on like reusing the FizzBuzz for other purposes, like maybe you want to do FizzBuzz fizzbuzz 5 for some reason, then you could try this. Here, let me print a new line between it. I'm just gonna print like a bunch of equal signs here. This way it's easier to read. Okay, let's do one more. All right, so you see how I'm kind of like reusing the method up here. So now I can just rerun it and we should see a bunch more output. So it does all the way up to 100. That's over here. There's a bunch of lines, and then we reuse the method to print 0 to 5 again, and that's what's happening right here. All right, people kind of getting a sense on why we use methods. It's kind of hard to see right now, but the theme is modularity, like taking things apart so we can maybe reuse them in other pieces. All right. Okay, let's do a couple more examples, and then we'll move on to the midterm stuff. Okay, so let me save this. Okay, quit. What else? Maybe we could redo roulette. It's not going to be a major change. We're just gonna, yeah, let's do roulette. So I'm gonna revisit this example over here. You see how our main is getting kind of large? It's getting kind of large. In some companies, they're going to limit you to a certain line length. So I think Google, here, let me check. Let me look at the Google style guide. So a lot of Silicon Valley companies use a style guide. So it's not just Google, it's a bunch of other companies too. And basically a style guide defines how your code should look. So let me look at the Java style guide. I'm just curious. I'm not sure what the line, if they have a cap on the line length. Let's see, formatting. Is there something on methods? Let me see. Methods. One statement per line. Okay, I'm not sure, but if you dive through this style guide, there's probably going to be something on how many lines there should be in a method. Let me see. Column limit? No. Column limit is like how many characters you can have on one single line. Let's see. Could be around here. Let me check formatting. Column. No, I'm not too sure. I gotta dive down this a little more. But anyways, our main is getting kind of large, and it would be arguably easier to read if it's if we had like less lines of code. So let me just run this real quick. It's been like 3 weeks since we've seen this example. So let me just run it real quick so people remember what it does. This is a roulette simulator. So roulette simulator, let me see, Java roulette. So this program is pretty much looping input. It's looping input and kind of checking to see if it equals some number. In particular, this for loop, if you might remember from a few weeks ago, this for loop says that we can only play less than 5 rounds, and we can only play when our bankroll is positive. You see this condition right here, that this condition is controlling when we do the loop. All right, so let's let me run it real quick. So it says, how much are you wagering? Let me type in like 10 bucks, enter. And now it says, what number are you betting on? I'll bet on the number 0. 0 is on the roulette wheel. So let me say enter, and then ball landed on 20, so I lost. Now my bankroll is this much, and we loop back up. right? We loop back up, round increases to round number 1 because we start counting from 0. So round is now 1, and then we check this condition. Is this condition still true? Right, yes, it's still true because 1 is less than 5, and our bankroll is still positive. So this is still true, and that's why it's still running. Okay, so let me just do it again. Let me give a bet $10, and then 0, and it should do this for like a couple more times. And then here it is. I'm on the last round right here. So I'm on the last round. I lost, and then now I have $150. So this condition becomes false at some point. Right? It becomes false because our round exceeded this number here. All right. So yeah, this is just a really quick refresher. There's some room for modularity. We can take things apart because there's some places that can be reused in other games, right? Like you don't have to think of this as a single roulette game. Maybe imagine you're designing a casino that has a lot of different games. A lot of those games will rely on the same method, so it might be useful to define them and reuse them later. All right. So here, let me build this from the bottom up, and people will kind of see what I mean. Let me. Well, wouldn't it be clean if our for loop was a lot smaller? Like, technically, this whole for loop body is simulating a single round, right? It's technically simulating a single round. So, what if I delete this and imagine if there was a method called simulate round? Right? Imagine there was a method called simulate round, but this will give us some number. Right? Like imagine if it gave us a number that represents our profit. Okay, profit can be positive or negative, by the way. So imagine if we had like an integer profit is equal to simulate round. People see what I'm trying to do here. Here, let me remove this comment over here, just so it looks a little cleaner. Okay, let me okay. I'm gonna have to rearrange a couple more things, but yeah, just focusing on this for loop here. You see how like easier it is to read? It says for some amount of times. Here, let me just actually I'll leave it like this. I was gonna simplify it, but yeah, for every round we're gonna simulate one round, return a profit, and capture it here. So then we can use that profit and update our bankroll. Right, so we could say bankroll is equal to bankroll plus profit. Now once again, profit could be positive or negative. It just depends whether or not we won. Right, so you see how easier this is to read? This kind of means we should design a method that returns a value. So I'm trying to point out this picture over here. This black box right here. See this black box? It's we did an example of this somewhere over here. Let's see. Like this right here, roll dice. We did this a couple days ago. This is an example of a non-void method. It's non-void because we're returning a value from some sort of black box. All right, so the in this case, last time we did like a roll dice. You don't have to worry about the roll dice. All you gotta focus on is the flow of this. Like when we invoke a non-void method, we should prefix it with a not void. All right. So, but based off this, how would we design this method here? Right. Well, let's see. So defining a method, the syntax of it. Well, we start off with the return type. So in this case, can you tell Can you tell what type this method should return? It's an int. We can kind of see that because on the left we're trying to capture it. We're trying to store it as an integer. Okay, so I'll have the return type be an integer, and then next we need the name of the method. All right, the name, I called it simulate round. Okay, and since this is a non-void method, it means it's supposed to return some sort of value. So it's usually a good programming practice to return a dummy value just to make sure things are compiling right. Okay, so let me go ahead and return a dummy value. I'm just gonna return like I'm just gonna return 10, or I'm just gonna return I'll just return 0 actually. So return 0. This I'm technically hard coding here. I'm hard coding a 0 profit every time, just to test it. So let me run it real quick. I'm running out of room here. Okay, let me test it. So Java roulette, and okay, cool. So what's happening here? Let's see. So I just played the program and it's kind of running it 5 different times. It didn't give me a chance to typing anything because I removed all of that logic. We're gonna end up retyping that logic here later. So yeah, it's pretty much simulating around 5 different times, but it's returning 0 every time. So that's why our bankroll is still the same. All right, so so yeah, this is always true right here. All right, if I were to return 10, hopefully people might see what happens. If I return 10, this is like saying the profit is 10. So this profit will always be 10. Let me go and test it. Run it, and you see how we're simulating 5 rounds. Okay. So let's complete this function method. I mean, let's see. Let me delete this. So what does it take to simulate a round? All right. Well, it takes 2 inputs. Remember earlier we need to tell how much to bet, and then where to put that bet. So we should probably set up an input so the user could type things in. All right, so let me go ahead and prompt the user. I'll do print f actually. So like, how much do you want to bet? All right, how much do you want to bet? And then put a $sign right here. Okay, cool. And then let's say the user types something in, so we should probably set up a scanner. By the way, our previous scanner lives in the main, and the scope, you might remember the scope defines the lifetime of variables. So the main scope is represented by this curly brace. This means that the scanner only exists in the main method. All right, so it's going to be necessary to move this into this local method here. All right, so let me go ahead and move it. Let me go ahead and move this input over here. All right, so scanner inputs, and then now we could take input. So we could say something like input.nextInt. This returns a number, and it might be useful to store it. I'm going to store it in a variable called wager. All right, and then next up, we just need to prompt a couple more times. So let me go ahead and prompt for what number do you want to bet on? Okay, what number are you betting on? And then go ahead and take input again. NextInt. Store this in some variable. I'll call it like guess. All right, so store in guess. And yeah, so these are 2 inputs. Let me make sure it compiles real quick, just so I don't see any typos. Let me let me see. So Java. Okay, this is perfect. Missing return statement. Yeah. So it's pointing right here. Basically, the compiler is telling us that we broke a promise. So our simulate round was a non-void function, meaning that we promised to return an integer. I'm gonna return 0 for now. I just want to make sure everything compiles and runs logically. Okay, so let me just return 0 real quick, and then let's run it. Okay, cool. So we're now inside of this simulate round. All right, we're waiting in here for a next integer. So let me type in some numbers. 10. What number are you betting on? Let's go 0. And then okay, cool. And then bankroll is 200. Bankroll is 200 because we returned 0. And then put the 0 here. But by the way, folks, if you're on the recording, I highly recommend maybe pausing the video and trying to fill in the blanks. Right? Some people might be predicting what's happening next, and that would be a good idea. It will be a good practice, right? Kind of predict what is going to happen next. All right, so what should we do next? Because our program doesn't really spin a wheel, and our bankroll is always remaining the same. Let me quit. Control C. Control C will emergency terminate. All right, what should we do after this? We should probably spin the wheel. Okay, and spinning the wheel is pretty much just generate a random number between a certain range. So it might be useful to grab this declaration here. Right, this RNG object only lives in the main, so it might be useful to bring it up here. Let me bring it into the method, and then now generate a number. All right, so let me just look at the documentation real quick, just to see how to use the random class. All right, so I'm trying to figure out how to generate a random number between 0 and 36, because that's the roulette wheel. It's got 0 to 36 numbers. So let me just look. So there is a method here called nextInt. It returns an integer. So this is probably, oh no, we should use this one over here. We should use this method because it takes an argument. The argument represents the upper bound. So we have more control over the range if we use this method. Okay, so let's use that. RNG.nextInt, and then I'm putting 37 here. I'm putting 37 because 37 is not included, and roulette is 0 to 36. So if you see the documentation here, we can see it's exclusive. Exclusive means it's not included. All right, so let's. This returns an integer, by the way. Remember you saw that in documentation? It returns an integer, so you might want to store it. I'm going to store it in like a variable called roll. So this is like spinning the wheel. All right, so you can imagine like spinning wheel. Imagine a print statement that says spinning wheel. I'll just put a space here. Okay, spinning wheel, and then we spin it here, and then now we can go ahead and print it. All right, let's go ahead and print it just to see where the ball landed on. I'm gonna use a printf. A ball landed on some number. Okay, I'm gonna test it right here, and then just to make sure the spinning wheel is working. Okay, so Java. Okay, how much do you want to bet? Yeah. So all we're doing is looping this. I know you don't see a loop in this method, but the main has it. All right, you see how the main, this is the loop, and we're just doing this method over and over again. So let me test this. 10, 0, spinning wheel, ball landed on 22. Okay, looks kind of random. Let me go 10 again, 0, ball land 33. Okay, cool. It's looking good. What should we do next, folks? Let me quit this. Quit. What should we do? Well, this simulate this roll here. We should make a decision. because you see how this method, we're attempting to capture some sort of profit, right? And the profit depends on what the ball lands on. So we should make a decision here, right? We should make a decision whether or not to give them positive money or negative money. All right, so you can imagine like an if statement, like an if and else. You can imagine this is like the victory branch, and this is like the losing branch. So let's say the victory branch. You win. Right, and say this is you lose. You lose. Okay. What should the conditions be? The condition is if the guess equals roll. Right, this is when we got it correct. And if we get it correct, we should probably return a positive profit. You know, remember that, like if we land it, we should return a payout of 35. All right, so, oh, I need to bring this variable up, by the way. I'm gonna bring this into the method over here. So it lives locally in here only. Okay, so now we can just return a positive amount of money. Right? We can just say return a profit, but the profit depends on the wager. So we can say wager times the payout, which is right here, straight payout. All right. So this is saying return a big positive number. And then if we lose, what should we do? What should we return here? We should return the negative wager because they lose that. All right. And then technically this is never going to be reached, by the way. This return 0 is never going to be reached. So it doesn't matter if you delete it or not. I'm gonna delete it just to see what happens. Okay, just delete this. Okay, Java. Okay, cool, it runs. And then let me test it. So 10, 0. Okay, landed on 4, I lost. Bankrolls this. Let's go 10, 0 again. You lose. Okay, 0, I lost. And then, oh, I finally won. So check it out. I typed in 10. I bet on 0. Ball landed on 0. So I finally win. But the way our loop is set up is it's going to terminate at some point. It's going to probably terminate when in the next round, because I'm on round like 4 probably. So when I reach round 5, this is going to become false. Let me test it. Maybe do one more bet. Yeah, I did one more bet, and then now it forces me to quit. Thank you, come again. All right, so let's summarize what we did here so far. You see how clean our main looks now? There's this simulate round thing here. There are some design decisions that are questionable. In my opinion, this is not really a good design. There's better designs. Like you could take things apart a little further, because some of these pieces can be reused in other games. You know what I mean? In this case, this is a pretty big method, but the goal was just to see how to clean up certain things and make things a little more readable. Right? In the future, you'll want to kind of decouple things a little more. Decouple means to split things apart, so future things can rely and reuse things. So yeah, you see how clean this is right here. This is our main, and you can collapse this if you want. All right. Well, once you verify the method is fully working, you don't really have to look at it anymore. So you could collapse it, and yeah, here's our main. Pretty sick, right? Okay. Cool. So with this in mind, I would probably spend a bit of lab time seeing if you could redesign your old programs. It would be a good use to look at maybe the taxes assignment. All right, one of our first assignment was taxes. Your main could probably be super clean now. If you were to write a method, imagine if you wrote a method that takes an annual gross income, right, does something with it, and then returns a double. Right? This would clean up your main so much if you did this. And then for the loon generator, this is a little trickier. There are some questionable design decisions that you'll see here, but you don't have to follow these methods, right? You can take it apart however you want. But one way you can represent the most recent assignment, loon generator, you can implement a couple functions. Like you can implement get modified sum, and then another one called get check digit. Right? These are methods that will help small pieces of the problem. So then you can use those small pieces to put together some sort of thing. All right, so here, let me make this a little more concrete for the loon generator. For folks who finished this assignment already, it would be a good use of lab time to try and redesign this. So let me help folks think about it. Let's see, let me pretend I made a project here. This was like project something. I think it was called project 4.3 or something. I think it was called project 3. And then let me call it a loon generator. Okay. So one way you could design this program is, well, first you should probably generate a random number. So let me imagine like int random number, random 7-digit number. All right, it's equal to dot dot dot. I'll let you fill this out later. So imagine you generate a 7-digit number. Okay, I'll leave this as a to-do. And then if you were to have some small helper functions, like something that calculates the modified sum, you can imagine that you would put that there. Here, let me rename this to R. I'll name it to rand num, just because it's smaller. Imagine if we calculated the modified sum, like get modified sum. You have to review the assignment if you're not sure what I'm talking about. But a get modified sum, imagine if we put rand num in here. Now this is part of the equation. And this, you can assume it returns an integer. So you can say like integer modified sum is equal to this. Hold up, let me change these to a camel case. Okay. So imagine you get the modified sum, and then next you just need to get the check digit. All right, so then you can go get the check digit equals get check digit, but the check digit depends on the modified sum. So you could put this as an input here, and then once you have the check digit, right, all you have to do is add this to the end of the random number. You see what I mean? So let me put a to do here. So to do, add or append. Append means to kind of glue it to the end of the number. So you could append the check digit to the random 7-digit number. All right, so yeah, if you were to implement two methods outside of the main, you can use them down here, and it's gonna be super easy to read. All right, there's some benefits in this. I do want to mention that the modified sum and the check digit, this is used in a lot of other algorithms. It's not just for generating barcodes, but in a lot of like data analysis and kind of checking for security stuff, you'll see something called checksum. You can look this up if you're curious. Checksum. This is like a way of verifying if a data is authentic. And yeah, it's not just credit card stuff. So yeah, if you were to write these methods, you could reuse them in other algorithms. All right, people see how clean things can look, and what I mean by modular, right? But modular means you can fix things easily. Like if you know that this method is broken, you can just go up here and fix it, right? And then you can comment things out easily. You can be like, oh, okay, this is broken, so let me comment it out and fix this over here, right? So it's yeah, I would recommend doing this as a lab time. If anyone wants to do that, please feel free to show me in the lab report or something. I'd be happy to take a look at it. It's a really good practice. Okay, let's move on though. That's about it I wanted to cover for methods. We really just wanted to apply it to a few other programs. So we're not done with this topic yet, by the way. We'll have to talk about it next week. On next Wednesday, we'll cover over more things. We'll talk about something called a Java doc. This is pretty cool stuff. It's gonna talk about how to generate like websites. Pretty much, you can pretty much generate websites just by putting comments in your code. So we'll do this. We'll talk more on like modularity. Like what does it mean to have spaghetti code? It's as we write bigger programs, it's easy to have spaghetti code. So by the end of this topic, we should kind of see what clean code can look like. All right. So let's stop here. We'll continue this next week. If anything, we should spend the rest of the time just talking about the midterm. Okay. The midterm, there's a practice exam here. You can take a look at it over the weekend or right now. But the practice midterm, this has no effect on your grade. It's really just here so you can practice the style, like the format of it, right? Like there's gonna be some multiple choice. There's gonna be fill in the blanks. There's gonna be some free response questions. So you can go ahead and try it out. Let me take the quiz and take a look at it. There's a code of conduct, by the way. So on the actual midterm, there's going to be some code of conduct that you should take a look at. So here, let me go ahead and take the quiz real quick. Okay. Cool. So the quiz is kind of like the midterm, I mean. It's a variety of different questions. We got fill in the blanks. Oh, I need to change this question. Okay, I'll change this right after the recording. But yeah, there's multiple choice here. Let's see. We got some questions that says, hey, what is the output of the following code? To kind of test if you can read code. Now these are snippets, by the way. These are code snippets. So you don't have like the void main and all of that. So you can assume certain things. Speaking about assuming, there are some free response questions down here. If a free response question is ever ambiguous, please state your assumptions. I have a comment all the way up here. Let me pull it up. So for the free response question, there's no need to like write the whole boilerplate, like the void main and all of that. If a question asks you to write a loop, just to save time, there's no need to like set up the main method and all of that, right? Just you can just do like a code fragment. And then if there's any ambiguities, Like if you're not sure what a free response question is asking, feel free to state your assumptions. Right, just this way there can be some partial credit. Right, there can be a lot of partial credit if you like say, oh, I'm assuming you want to do this, and then I'll grade it with those assumptions in mind. Okay, so yeah, you can take a look at this stuff over here. The exam is timed for 90 minutes. So this is a practice midterm, meaning you can take it over and over again. So don't worry if it closes on you. I think it auto resubmits after 90 minutes, but you can just retake it because it's a practice one. All right, but the actual midterm will be timed for 90 minutes. So yeah, please be aware of that. There's a timer over here. Right. Okay. Any questions, folks? You all good? Okay. Cool. That's it for today. It's really just a catch up day. We went over previous material from last class, and we introduced the midterm. Okay. Thank you all, folks, and I'll see you all next week.